And then we're gonna go ahead, we covered 1.1 in class on Tuesday. If you were not here, I posted the video on that on Moodle, so go back and take a look at that. And then we're gonna start 1.2 today, so. All right, so the one of the quiz that some of y'all missed, it was question 10. And it said factor, and it was 1 minus 8x squared minus 9x to the fourth. So this one looked a little bit different, mainly because it was written differently. And obviously it's a 3-term, there's no GCF here. So because it was 3 terms, it's not gonna be like a difference of squares or sum of cubes or difference of cubes question. So even though it's 3 terms, we can still take this last term and multiply it by the first term. Remember, it's 3 terms, so we can do that. And we want 2 numbers that multiply to give us -9 times 1 is -9, but adds to give us this -8. And even though there's an x to the fourth and x squared here, that's okay. All right. So what would these 2 numbers have to be? What are 2 numbers that multiply to give you -9 but add to give you -8? Good. Casey said did you say -9 and 1 too? I'm struggling today, guys. I have a really, really bad headache, like almost not able to stand up here and do it, but I'm gonna try to make it through. So, all right, so -9 and 1, -9 times 1 is -9, -9 plus 1 is -8. So this is going to break up into a -9, and because it's the x squared up here, we're gonna use the x squared instead of just an x, okay? And this is gonna be a 1x squared. So now I have my 4 terms, and we can still put these in the box, okay? This is gonna be a plus, this is gonna be a negative. So in my box, I'm gonna put 1, -9x squared goes here, 1x squared goes here, and -9x to the fourth will go there. So what do these 2 have in common? They only have a 1. Notice your negative here is on both of these. I'm gonna bring out a negative. They both have a 9. And what else do they both have in common? Notice there's an x squared here, and this is x to the fourth, so that means x squared. They both have 2 x's. All right, these don't have anything in common, so I'm gonna put a 1, and these have an x squared. Okay. So I have 1 plus x squared and 1 minus 9x squared as my answer. Questions on this? Now, I look at those 2 and I say, can I factor those further? Can I factor either one of those further?
Yeah.
Yes, which one?
The 1 minus 9x squared.
Mm-hmm. So this one's a plus, it's 2 terms, so remember with 2 terms, we check for difference of squares, sum of cubes, difference of cubes. This one has a plus, so I'm not gonna go do anything with that one, it's not a cube either. This one has a minus, this is a perfect square, and these are perfect squares. So this is going to break up into a 1 and a 1. My minus will be a minus and a plus. 9 will break up into a 3 and a 3, and your x squared will break up into an x. And this should have been your answer. A lot of y'all missed that one. Okay, questions on this one? It was probably the best missed question, I would say, out of all of them. I think everybody, for the most part, did really well on the quiz. So All right, so we're gonna go ahead and move on to 1.2 notes, which is on solving linear equations and then also solving rational equations. Anybody know what we would do first? What's the first step in solving equations? Anybody remember? Or what's the goal in solving equations? Like a linear equation. So if I had something like this, 2x plus 5 equals 15. I'm sure you guys can explain to me what you would do to solve this, right? It's a linear equation. What's the goal?
Trying to get x equals the number.
Right, try to get x equals a number, so get x by itself, right? So I'm gonna say, and it's not always x, it might be y, might be z, might be z. So I'm gonna say, get variable, which is your x, y, z by itself. That's the goal, okay? And to do that, we're gonna have to move things. Good job, guys, you guys
So we
did something.
can
Yep.
go to 15.
So I like to circle where the variable is first. Okay, so the 2 is with the right now, so I can't touch that. So I need to move the 5 over, and the way that we move the 5 over
Subtract.
is subtracted, right? And I can line these up because these are like terms. Okay, so I have a 2x equals 10, and then the last step now is to get this by itself. And these are being multiplied, so we do an inverse, and so we divide. The nice thing about these is you can take these and plug it back in. So step 1 is get variable by itself, and then the last step would be to check answer.
The checking answer confused me. I solve it. Don't check it.
Well, okay, so how would we check it? Well, you found that x equals 5, right? So wherever there's an x, what's gonna go in place of it? A 5. So this is, you read this as 2 times 5 plus 5, is that equal to 15? 2 times 5,
It's 10.
10, plus 5, is that equal to 15?
Yes.
Yes, I know I did right. Okay, so this is pretty basic equation. We can make these more complicated, obviously. I'm gonna try to give several examples of these. Here's another one. Hopefully this is a review, right? I think you guys have been solving equations since math 1, at least. All right, try this one. This one's a little bit different because you've got 2 variables, one on each side. And again, some of you guys may move something different first. Oh, okay. I got you down, Phoenix. All right, so this one, what would you guys move first?
I did it 2 ways.
Okay.
I gotta make sure it's correct.
Yeah.
First what I did was I moved the negative, the 32 make it a negative.
Okay.
So you get negative 2x.
All right. So we're gonna move the 3x over. This becomes a 1x minus 3x, that's a negative 2x equals 4.
Then I divide it by the 2.
Don't forget the negative.
So I get negative 2.
Good. Now, you could have also, if you wanted to, move the 4 over and then move the
That's
1. That's the other side, okay. So really, it doesn't matter, I don't care which way you guys do it, that's why I said, that's why I've always liked math, I'm a math person, because I like to know that I'm right, in math, there's just multiple ways you can check yourself. Or try different things, like if you can't get it one way, then try it another way. And then I like to take this answer and plug it back in to see if it works. So if I did that, I would do 3 times negative 2 plus 4. So I'm plugging the negative 2 where the x is that equal to negative 2? Okay, because that's where the x is, right? 1 times negative 2 is negative 2. So 3 times negative 2, so we give you negative 6 plus 4, is that equal to negative 2? Yes, it is. So I know I did it correctly. Okay, so if you had moved the 4 over and then moved the 1 over, that is fine too. A lot of teachers, when they teach it, they like the variable to be on the left-hand side. And so they tell students to move the variable to the left-hand side. It really doesn't matter though. This right here means the same thing as this. So whatever you guys like to do. All right, let's do a couple more of these and they'll get a little bit more complicated as we go. Guys, go ahead and work on that one that I just wrote. Try those other two that I put up there too.
This, it cancels out.
So I like something. All right, move that.
Okay.
Okay. All right, now move the 4x over. So you're gonna get, what are you gonna get over here? Right, so 0 equal to opposite 3. Is 0 equal to 3?
No,
No, so what do you think the answer will be?
like not, I don't know how to pronounce it, non-solution.
That's why I would have put one of these up here because, or just put no, just put no solution, or you can also put just. Classroom should see that too.
Yeah, that's why I use your number.
I wanted to do one of these so that way y'all can see. Technically, there's 3 different answers you can get. No solution, all real numbers,
Yeah,
or an actual x equal.
I get them mixed up. I'm
Yeah.
fine.
But think about it like that. If you do it all the way and you get a number and it's not equal to the same number, if they're not equal, then you know it's gonna be that. All right, so let's take a look at this first one. You're gonna need to use a distributive property before you can move anything, okay? So if you remember, the distributive property just means that you're gonna take this 2 and you're gonna multiply it by the 3 and the 2x. So 2 times 3 is gonna give you 6. 2 times 2x is gonna be 4x. And then the same thing for this side. So 3 times x is 3x. 3 times -4 is -12. And that's called the distributive property. Now it really just depends on what you wanted to move, okay? If you like the x to be on the left-hand side, then you might have gone ahead and moved to this 3x over, okay? And you would get 6 plus 4x minus 3x is 1x equals -12. I'm gonna write this over here because I'm running out of room. If you move something else, that's fine, okay? You should still get the same answer. So now I want to get my 1x by itself. So I move the 6 over, and you get 1x or just x is going to be equal to -18. Everybody get that? And if you plug it in to check your answer, 3 plus 2 times -18 is that will be equal to 3 -18 minus 4. All right, so that's going to be what? 18 to 6, 36. That's going to be a -36 plus 3 times 2. That's going to be a -33 times 2, which is a -66. Is that equal to 3 times, what is that going to be, -20? Are those equal? All right, 22, excuse me. Yeah, those are equal. Okay, so that works. Did everybody get -18 as their answer? Okay. Did y'all do it a different way than I did it? Okay. All right, let's take a look at this one. So watch what happens when we solve this. We get 4x minus 4. Is that equal to 4x minus 1? All right, watch what happens. If I move the 4 over, okay, you get 4x is equal to 4x plus 3. And then I move this 4x over, so I'm going to write it here. 4x equals 4x plus 3. I'm going to move the 4x. And instead of just canceling both of these out, we know that this thing is 0, right? And you look at this, is 0 equal to 3? Are those equal? No. And if you think about it, if you look at this statement, 4x minus 4, is there any way that 4x minus 4 is going to be the same thing as 4x minus 1? Is there any way possible for those to be the same thing? No, okay? There's not a variable I could plug in there that's going to give you the same number. So if 0 is not equal to 3, what do you think our answer is going to be? It's going to be no solution, okay? So we can write no solution, or you can also use this symbol that looks like that with a little knot through it. All right. Same thing for this one. You can already tell that this is going to be no solution. But I did actually want to give you one that was not that answer. What if I had this? What if I had this one? Are these the same? It's going to be all reals, yes. So if you get a statement and you know these are the same, they're equal. So any number that you plug in there is going to work. If I plug in 2 here, they're going to be equal because they're the same, right? If I plug in 100 there, they're going to be equal because they're the same. And watch what happens to this. If I move 3x over, you get 0 here, right? If I move 1 over, you get 0 here. Is 0 equal to 0? Yes. So anything is going to work. So you would put all real numbers. Anything will work. Okay, so I didn't have that originally, but the other question was no solution again on that one. But I wanted you guys to know, so technically you have three different types of answers for linear equations that you can get. You can get an actual X value or a variable number, whatever you get, a number. You could get no solution as your answer, or you can get all real numbers as your answer. Okay, questions on this? All right, let's give you another one. This one's a little bit more complicated. So we'll see how you guys do on it. So looking at this one, can anybody tell me what are you gonna have to do first? The box or foil, okay? So technically, it's gonna end up being a quadratic on the left and a quadratic on the right, okay? So you're gonna have to foil or box, either whichever one you wanna do. And you're gonna have to do that on both sides, and then you're gonna be able to move some stuff around. It's gonna turn into a linear equation.
Let's bring this up. What symbol should be in front of that? Oh, you got a negative, but then you did put it. You see that? So 2x, that should be a negative 2x, which is gonna change that number, which is then gonna mess up everything else.
Yeah.
Okay, so fix that and then go from there.
Okay.
But I mean, everything else is like, let me check this one too, it's weird. Got a negative on this. Good, okay, so fix it from there.
All right, so let's take a look. I'm gonna do the box for this one and then I'll do foil for the other one. For those of you that like foil. All right, so 2x times x is 2x squared. -1 times x is -1x. Remember, you've got to bring the signs, whatever signs you have in front, bring those down, because if you don't, it's gonna mess up the whole problem, okay? 2x times -1 is a -2x, and then -1 times -1 is going to be a +1. So when I write this down, you end up with 2x squared minus 1x minus 2x plus 1. And we combine these two, and a -1x and a -2x make a -3x here. So I'm going to bring this over here, 2x squared minus 3x plus 1. Okay, do you guys see why I go back over this stuff before we get here? Because a lot of people forget all this. That's why I like to review a little bit before. All right, this one I'm going to do FOIL. So x times 2x is going to be 2x squared. X times -5 is -5x. -5x times 2x is -10x. And then -5 times -5 is a +25. And then I'm going to combine my like terms in the middle. And so you end up with 2x squared minus 15x plus 25. Did everybody get that? All right. Caleb, did you get this?
So working on it.
Okay. All right. I want you to get caught up with me real quick so you can pay attention to this. Did you get this part right here when you redid it?
Yes.
Okay. All right. So now let's see what happens. Okay. Right now, does everybody understand that this is a quadratic and this is a quadratic? How do I know that it's a quadratic? Doesn't have 3 degrees. It has 2. A degree is 2. It's got 3 terms.
Yeah, that's what.
But this is squared. So because there's a square to degree is 2, that makes it a quadratic. Okay, we haven't really got into quadratics, so you might not know that because we really haven't got into it yet. But, and we're going to talk about solving quadratics later on, but not right now. So watch what happens. If I line up my stuff here, I'm going to move this over, right? So I would subtract 2x squared, and I'm going to line it up underneath the like term. What happens to these?
They cancel.
They cancel. And so now I'm left with a linear and a linear. And why is it linear? Because it just has the x variable. So this becomes -3x plus 1 equals -15x plus 25. Okay? Now it's a basic linear, and you can kind of move what you want to. All right, I'm going to move the variable over. So this is going to be plus 15x plus 15x. I'm running out of space here. I'm going to rewrite this up here. So this is going to be -3x plus 15x. That's going to be what? 12x plus 1 equals 25. And then we subtract the 1 and you get 24 equals 12x. And then I'm going to divide by 12. And so you get x equals 2. Did anybody get 2?
Yeah. How'd you get to?
You're about to?
Mhm.
Okay. Now we can check that to make sure it works. Watch. 2 times 2 minus 1. And then 2 minus 1. Is that equal to 2 minus 5? 2 times 2 minus 5. All right. 2 times 2 is 4. 4 minus 1 is 3. Is 3 times 1 equal to, this is going to be a -3. 4 minus 5 is a -1. 3 times 1 is 3. -3 times -1 is 3. Positive 3. So they're equal. So we did what we were supposed to. Questions on that one? Do we want another one like this? Try one more of these? Okay. So these go from a quadratic equations to linear. Which is why we still do it in this section, because technically it's still a linear equation. It just starts out. All right, let me find you guys. All right, you guys try this one. Now, remember what x plus 1 squared means. What does that mean? What is x plus 1 squared? Yep, it means 2 of those, right? So you just write it out twice. Everybody at Nursery should be working on this problem. Should be, see pencils moving. All right, we ready? So, we rewrite this as x plus 1 times x plus 1, because it just means that twice. You can do the box or FOIL, just for the sake of time, and do x times x is x squared, negative 1x, 7x, negative 7. And then this one's going to be x squared, 1x, 1x, and 1. And so when we combine these, you get what, 6x here? And 2x here. Okay? And so everybody got it this far? Okay. Then we move the x squared over, and what happens is they go away. And so you're left with this linear equation, which is just a basic linear equation, right? 6x minus 7 equals 2x plus 1. And then I'm going to move my x's over. And so we get what? 6x minus 2x is 4x. And then minus 7 equals 1. And then I'm going to add the 7. And so you get 8 equals 4x. And then divide by 4. And you get x equals 2. Okay? Everybody good? And I know it's right because the book tells me it's right. So I'm not going to check this one. All right. Any questions on this? All right. The next part is on solving rational equations, which can make it a little bit more complicated. So what I can tell you is a rational equation is going to end up giving you another linear equation. Hence why we do it in this section. Does anybody know what a rational equation looks like? What is a rational equation? What do you think of when you hear the word rational? What is a rational number? Yeah. You might tell me what a rational number is? Anybody at NERPA?
Real. That's one you said.
Real? I mean, it is a real number, but. Yes, that is correct. It is a fraction. Okay?
Wow.
Yeah, that's why people don't like it. That's exactly right. Because you know why? Because y'all don't like fractions. And I can tell you, my fourth grader, y'all start out in elementary school not liking fractions, and then y'all follow all the way through. And fraction's just it's just another number. Every number that we use is a fraction. You guys realize that, right? 2 is a fraction. What fraction is 2? Every number is over 1, right? Every single number. So we do fractions all the time, every day. All right, so let's look at so rational number. Let's just review fractions real quick. If I have 1/2 and I'm adding the number 3/4 to that number, we got two rational numbers here. Does anybody remember how to add these fractions? I'm going back over it. Been a long time, right?
It's last semester.
Oh, really? Okay.
I'm really just bad at fractions.
Add the top, but keep like the biggest number on the bottom, it's like 4.
Well, what's that called? Okay, somebody said it. You're doing it. You just don't know what it's called. So common denominator. Okay, so he said keep the biggest number on the bottom, right? But it's because we want a common denominator. Can you change 4 into 2 without changing the number? No, you can't. Okay, but could you change 2 into 4?
By adding it.
We can't add it.
Oh.
We can multiply it, but we can't add it. So the common denominator on this one would be what?
The 4.
The 4, okay? So the only thing that I would have to change here is this 2. The 4, this one's already 4, so we don't have to do anything. So what would I multiply this by to get a 4 on the bottom? Because that's the only way I can add fractions. You have to have a common denominator, a 2. So what you would do is you would take 2 times 1 is 2, 2 times 2 is 4. So now, and did we change this problem? No, because 2 over 4 is still the same thing as 1/2, correct? We didn't change the problem. So that's the main goal for these, is being able to rewrite something without changing the problem. So now we add straight across and we get 5 over 4. Does that make sense? It's just how you add fractions, okay? Multiplying fractions, you just multiply straight across, and it's nice and easy, but add. So this is going to be the same concept that we're going to do with these equations, okay? All right, so let's look at one. We just said in solving rational equations, you must have a common denominator. And again, the denominator is the bottom number. Okay. So, do we see the difference in this kind of equation versus what we've been doing? This is a rational equation because you have this variable in the denominator. Okay, that's the difference. Now, if I'm looking at this, you might be a little confused because this doesn't look like a rational number, but I know that it actually is a rational number. And how can I rewrite this as a rational number? Put a 1 under it, okay? So now I have 3 fractions here. And the only way that I can solve this is to have a common denominator. So look at our denominators. I have an x minus 2 here. I have a 1, and I have an x minus 2. What would you say, looking at all those numbers, is the common denominator? X minus 2. This one already has x minus 2, so I don't have to touch this. This one has a 1, and this one has an x minus 2. I don't have to touch this one. So the only thing that I have to change here is this one. And how would I do that? Okay, but that's not what we wanted. If I times it by -2, this is just gonna be a -2 at the bottom. What do I want? The x minus 2. You think about it as a whole thing. We can't break it apart, okay? So you're gonna multiply this by x minus 2. Just treat this like a number, okay? And you're gonna do, and whatever you do to the bottom, you have to do to the top because you don't want to change it, okay? Think about it. If I did x minus 2 on the top and bottom, like this is still a 1 because if you divide those two, it gives you a 1, right? So I leave this one the same. This becomes 3 times x minus 2 over x minus 2. And again, I have not changed this because look, if you divided those, you still get 3, right? These would cancel each other out if I actually divided these out. Equals 2 over x minus 2. Is everybody with me at NERSPO? So now, notice, what do I have here on the bottom? X minus 2 all the way across. The nice thing about rational equations is when you get a common denominator, guess what happens to the denominators? Anybody know? If you have an equal to here, they all cancel out and it becomes a linear equation. That's why we do all this. So once you have a common denominator, then you can cancel all the denominators and you're left with a linear equation. Left with top, which equals a linear equation. So this all goes away. And now I'm just left with the top, which is this x plus 3 times x minus 2 equals 2. And then this is just a basic, what we've been doing, right? So the hardest part is that common denominator part and figuring out the denominator. So if I simplify this, x plus, this will be 3 times x is 3x. 3 times -2 is -6 equals 2. Okay? X plus 3x is going to give you a 4x minus 6 equals 2. I'm going to move this 6 over. You get 4x equals 8, and then divide by 4. You get x equals 2. Okay? Now, the hard part about rational equations is to remember to check your answer. if I plugged in this 2 back up here in the original equation, would it work? If I plug 2 back up here, would it work?
No.
No, why?
I'll have to work with it.
If I plug 2 in here, what does it give you on the denominator?
0.
A 0. And can you put a number over 2 over 0? What if you put 2 over 0 in the calculator, what's it gonna do?
Error.
Error. Okay, so it's not possible. You can't have a 0 in the denominator. That's one of our rules. I don't know who came up with it. I don't know where it came from, but it's a rule, okay? So when you plug that in, this is the answer that you got, but it doesn't work. So you know what your answer would be? No solution. The answer on this will be, I just picked this one out of the book, but it worked out. I mean, I really wanted to give one that actually works first, but, so the last thing you should do is plug answer back in to see if it works. All right, if you don't got this yet, don't stress, because we're gonna do a lot more of these on Tuesday.
I believe that's not X.
No, it's really not it. This is actually called an extraneous solution, which we're gonna get into that more too. I'll go over the actual definition. Because you got an answer, but then when you plug it back in, it doesn't work. So really no solution would be the answer, like a trick answer. That's why some people don't like math, because they're like, why can't that just be?
Sound familiar?
Okay, we're gonna stop here. Tuesday, I'm gonna keep going over some more rational equations, so if you still don't got it, hopefully it'll click by Tuesday. It's not an easy concept, but this part, people struggle with this. So if you didn't get it, but if you want to work on some to try for the weekend, I could give you guys some problems to try. Oh, or you could just look up some videos on rational equations, and there's a million out there, okay? Do you guys want some problems or no? Because if you're not gonna do it, I'm not going to.
I'll watch it.
Yeah, that's fine. All right, you guys look up some videos on rational equations. I think I put some on Moodle too, but there's a million
Yeah.
up there, so. All right, have a good weekend, guys. I will see y'all on Tuesday.